Greetings to everyone. Welcome back. So today we are going to discuss types of corrosion. So different types of corrosions. We have basically three types. That is galvanic corrosion. Then we have differential aeration corrosion. It is also called as waterline corrosion or concentration cell corrosion. Then pitting corrosion. So first type, that is galvanic corrosion. So we know galvanic cell. So it is called as dissimilar metal corrosion. So it takes place when two metals are in physical contact with each other and are immersed in conducting fluid. So corrosion damage induced when two dissimilar metals are coupled in a corrosive electrolytic solution, that is called as galvanic corrosion. So galvanic corrosion compulsorily needs two electrodes and a corroding solution. Then, unlike other types of structural corrosions, galvanic corrosion does not depend upon the metal's texture, temper, etc. So it may occur with any metal as soon as two are in contact in a conducting liquid. So it works like a battery. So the appearance of galvanic corrosion is very characteristic. It is not dispersed like pitting corrosion, but highly localized in contact zone with the other metal. So the zone affected by galvanic corrosion often has a shinier aspect than the rest of the surface. Now, examples of galvanic corrosion are plate and screw of different electric potentials due to differences in processing. Then multiple component implants using different metals for each component. Then copper and steel tubing are joined in domestic water heater. So the steel will corrode in the vicinity of the junction. So this example you can see in houses also. That is the copper and steel tubing. Okay. So in water heaters generally the steel starts corroding. Why? Because it is mixed with the copper. So heterogeneity leads to corrosion. So this part you can see L. Then factors affecting galvanic corrosion are potential difference between the materials, then cathodic efficiency, then surface area of connected materials, then electrical resistance of the connection between the materials. So all these factors affect the galvanic corrosion. So for example, this is the galvanic corrosion which is taking place. Zinc getting oxidized to form zinc residual ions and copper taking electrons to form copper. So the more noble cathode which is getting protected, and this is the electrolytic solution, and zinc is getting oxidized, that means it is getting fermented. So galvanic corrosion more reactive at the anode and less reactive at the cathode. So this is getting corroded and this is getting protected. Right? So zinc is getting corroded and this is getting protected. Next. Differential aeration corrosion, or it is also called as concentration cell corrosion or waterline corrosion. So as the name indicates, we can see that this type of corrosion takes place when a metal is unevenly exposed to different air concentrations or oxygen concentrations. So concentration of oxygen will be different in this. Okay, the part which is exposed to less oxygen undergoes corrosion. Suppose this is a waterline corrosion example. Okay, so here you can see the surface. Okay, so the surface of the water and here. Okay, so all this part. So what is happening is the surface of the metal is more oxygenated, right? Because we have atmospheric oxygen as well as the oxygen present in the water. Whereas beneath water has only oxygen present in it. That is the water part oxygen. So that is why this is less oxygenated part and this is more oxygenated part. So less oxygenated part undergoes more corrosion and more oxygenated part undergoes less corrosion. So that is why this is called as waterline corrosion or concentration cell corrosion or differential aeration corrosion. Whatever it means the same. Right? So at the anode there is less oxygen concentration, metal gives Mn++ and electrons, and at the cathode it forms hydroxy ions. Then coming to the third part, that is pitting corrosion. So pitting corrosion is a localized form of corrosive attack that produces holes or small pits in the metal. So the bulk of surface remains unattacked. So pitting means which has pits or holes in it. Okay? So wherever you find metal oxide layers with pits or holes, there pitting corrosion can take place. Okay? So pitting is often found in situations where resistance under general condition corrosion is conferred by passive surface films. So localized pitting attack is found where these passive films have been broken down. So the pitting attack induced by microbial activity such as sulfate, okay, reducing bacteria also deserves special mention. So pitting attack is also influenced by microbial activity like sulfate reducing bacteria. Okay? Not only by corrosion, it is also by bacteria. So this is the pits or holes which are formed on the metals. Okay. So corrosion pits are primary source of leaks in water handling systems. So here we have shown the jug, okay, jug of water. So pits can be formed in this. Okay. So if you take pitting corrosion, example iron. So you can take this pit. So here in this pit, this made up of iron. Okay, so iron getting oxidized and the water with oxygen forming hydroxyl ions. So these OH minus ions react with the Ag2 plus ions to form ferrous hydroxide. So here rust formation can take place. So putting corrosion on the surface of the iron can you can give it as an example. Okay. Then this is taken from the internet and slideshare videos. So we have to give them credit for developing these types of PPTs. So today's class we have studied about galvanic corrosion, then waterline corrosion, and then pitting corrosion. So in galvanic corrosion, two dissimilar metals undergo corrosion in presence of conductor liquid. In differential aeration corrosion or waterline corrosion or concentration cell corrosion, here you have two different aeration zones. Okay? So less oxygenated part undergoes more corrosion, more oxygenated part undergoes less corrosion. Then we have pitting corrosion where pits or holes are formed on the metal oxide layers and their pitting corrosion takes place. So all these three are important types of corrosions which are formed. Then examples you can give, that is zinc, and then for galvanic corrosion zinc copper, then differential aeration corrosion or waterline corrosion water filled in a beaker, and then pitting corrosion iron as an example where rust formation takes place. That is, you can write, I think, for pitting corrosion, you can write the absorption of oxygen also. The same thing can be written for pitting corrosion also. Thank you.